Yeah, Jishu, you can go ahead now. Yeah.
Okay, so first off, everyone, welcome to today's session. So to start our introduction today, I just want everyone to think about what we depend on to get the different energy which supports our home. Like, where do we usually get our electricity or our heat and our air conditioning? Usually these come from gas or fuel oils, coal, nuclear energy, a lot of energy sources which are quite harmful for our earth and are non-renewable. And only a smaller percentage of us use renewable energy like solar power, hydropower, etc. But there is one neighborhood which is fully sustainable, only using renewable energy, and that is the Geos neighborhood. This neighborhood, located in Arvada, Colorado, uses only solar power and geothermal energy. Our guest today, Darlin Chang, is an engineer pioneer and important figure from the Geos neighborhood. He studied energy in its many forms while earning a PhD in mechanical engineering, and he, along with his daughter, have been climate advocates, raising awareness about the urgency of transitioning our day-to-day lives away from fossil fuels. Today, Darlin will inform us more on this neighborhood, which is teaching us how an all-electric net zero future is possible. It's a great honor to have you here today, Darlin Chang.
Thank you very much for the introduction. And thank you all for joining. I really appreciate your interest and your taking the time to listen to me and also engage with me. So I plan to talk about four major topics. During my talk, if anybody has questions, please feel free to raise your hand or type in the questions. And when there's a question, please let me know. Please feel free to interrupt me so that I can address your question. So I'm going to talk today as if I were talking to my younger self who was still in middle school. And if I had the opportunity to talk to myself back in middle school, I think I would say what I'm going to say to you today. So the major topics I want to cover today is number one, what is energy? What does energy mean to me after spending a career in studying it? And why is our energy so full of fossil fuels? Then I'm going to talk about how do you become an energy pioneer. I started on my journey in energy more than 2 decades ago, and I want to help you along your journey and help you understand what it takes to be an energy pioneer. In particular, I want to help you understand what does it mean to be net zero and zero emission, and how to make sure that when you hear those words being said, that they really mean what you think they should mean. And then third, I'm going to talk about energy around the house, about the things that you can look at around your own house to help you understand what can be done, not only in our day-to-day lives, but throughout the world to help make this transition away from fossil fuels. And my final topic will be about what does it mean to be grown up? Why are the adults in the world not able to collectively make sure that humanity is grown up and that we're able to deal with this existential challenge, meaning this challenge that threatens all of us to be able to transition away from fossil fuels to renewable energy. So starting with what is energy? What does that mean to me? Well, I studied as an engineer. And if you don't know what an engineer is, it's like somebody who focuses on how to use science to make useful things out of it. So for me, I studied mechanical engineering, and that would be studying energy in its many different forms and creating machines that can harness that energy to do useful things that people need. So I started on my journey in mechanical engineering about 1994 to 1998. And then from 1998 to 2003, 1994 to 1998, when I was studying as an undergraduate at the University of Illinois, and 1998 to 2003 was when I was a graduate student studying for my PhD. And when I studied energy in the university, what I learned about energy is it's really an idea that people have come up with to describe what could happen and what is happening, and how when you add up what could happen and what is happening all at once, you have something that is constant, that is forever, that throughout time, energy is always the same. But this is a tricky thing because energy means all the things that could happen and all the things that are happening. So that includes the planets going around the sun, that includes the sun shining, sunlight. A very, very tiny fraction of that energy is actually available to life. And a very tiny fraction of that energy is available to people until recently, until people discovered something called fossil fuels, which is oil, gas, and coal. And to give you some perspective on what energy means in the grand scheme of things, I'm going to show you what it's like. I don't want to spend all my time telling you, so I'm going to show you how I think of energy. So the way that I think of energy is I think of it as possibilities, like a chessboard or a checkerboard, where you have alternating squares. But if you took the whole universe and you were to take our solar system would be smaller than the tiniest dot underneath my finger under one of these squares. And then if you took the solar system and if you took the Earth and life on Earth, then it would be the tiniest dot underneath my finger on the corner of this board as well. So in all of the universe, there's only a very, very tiny fraction of it that has energy that can be used by life. Before humans came along, that energy was the sunlight that came from the sun and shined on the earth. And that sunlight was harnessed by ancient plants, in particularly algae and ancient trees. And the reason why that algae and ancient trees are so important is because those are primarily what oil, gas, and coal came from. So those ancient plants, they harnessed sunlight for millions and millions of years, and they weren't recycled. Most life on Earth is recycled. So whenever they collect energy, they give the energy back when they decay and they're decomposed by other life forms. But through some accidents of ancient history, these ancient algae and ancient trees were buried underground before they could be recycled. And they were grown under conditions where there wasn't enough nutrients for bacteria and other life forms to decompose them. And during these short periods of time, these buried underground ancient plants got compressed with high pressure, high temperature, and they became fossil fuels. They became oil, gas, and coal. And humans discovered this oil and gas and coal. And for us, it's like an inheritance of millions of years of sunlight. That sunlight was collected by those ancient plants, and they're available to us all of a sudden because we can burn them. And when we burn them, we get heat, we get pressure. We can use those to run machines. We can use those to generate electricity. We can use those to run our cars. And that's why our life today is so full of fossil fuels, because humans tapped into an amazing inheritance. But along that inheritance came with a curse, because along with all that ancient sunlight that got trapped in oil, gas, and coal, we also got the carbon dioxide that was absorbed from the atmosphere by those ancient plants. And now when we burn them, we release the carbon dioxide back into the atmosphere. And we're not only releasing millions of years of ancient sunlight, we're also releasing millions of years of carbon dioxide. That carbon dioxide is overwhelming our Earth's capacity to absorb it. We don't have enough trees, we don't have enough plants today to be able to absorb millions of years of carbon dioxide that have gone into the atmosphere. So this is one of those things that I learned as a mechanical engineer. When you release energy in all of its different forms, there's always a cost to it. There's always something that gets released as pollution. And in the case of fossil fuels, that's carbon dioxide. So carbon dioxide, it's a big problem. It's creating a mess. It's also invisible. And that's one of the problems of human nature, that when things are invisible, we don't take it seriously. The carbon dioxide in the air, we typically don't measure it. But what I'm going to show you is one way of measuring it. I have a sensor here that is showing the amount of carbon dioxide that's in the room here. And that's this number here, this CO2 ppm. And as you can see, as I'm talking into it, the carbon dioxide is going up. And that's because I breathe out carbon dioxide. Like all mammals, all humans, when I release energy from food, I'm burning the food through chemical reactions in my body and releasing carbon dioxide. And that carbon dioxide goes out into the room, into the house. And if there's not enough ventilation in the house, you start to gather carbon dioxide within the house. And if the carbon dioxide level gets too high, if it gets to over 1,000 ppm, then that can start to cause noticeable effects. I can start to feel drowsy. I can start to feel fatigued. That's why it's a big issue in schools. If your carbon dioxide level is too high in your school, then you might not be able to pay attention. You might be drowsy and you might start feeling sleepy. And you might also know this from space capsules like the Apollo 13 mission. They were having a problem with their carbon dioxide scrubbers, and they were starting to feel drowsy because their carbon dioxide levels are going way above 1,000 ppm. And at some point, when it gets to around 1,500, 2,000 ppm, then people start to really have dangerous side effects. They might start to hallucinate. They might not be able to think straight. And we can see carbon dioxide levels within a room having a bad effect on us. But broaden this to the entire world. When we have carbon dioxide levels going up around the world because of all the fossil fuels that we're burning. And that is when we start to have problems of having droughts, having extreme weather events, and not being able to count on the climate that our civilization grew up in, to be able to grow our crops and to be able to maintain our civilization. So talking more about energy, what is it about energy that is so difficult to be able to not only harness it for our own use, but to also use it responsibly? And I'm going to show you another analogy that I'd like to draw upon. So I showed you before this this chessboard. Well, this would be the universe, and this would be us in our solar system. And then within our solar system, this would be us on Earth. But in our solar system, we also have a planet called Venus. And Venus is a planet that has far, far more carbon dioxide than we do. And that's because of all the volcanic activity that released the carbon dioxide into Venus's atmosphere. And in the entire solar system, in the entire universe, most of that universe is hostile to life. We only know that Earth can harbor life at this moment. And Venus is a planet that is closest in size and history to Earth, but it is so full of carbon dioxide that it cannot support life as we know it. Now, why on Earth would we allow Earth to become more like Venus? Well, the reason is because on top of this universe, on the planet Earth, we have a game that's being played, and that game is the economy. And the adults are playing this game of the economy. And rather than the rules of energy and the rules of the universe, what we've put on is our rules of owning properties and making decisions based on who has the most money and giving the most power to the people who have the most money to make the decisions. So that is why we in such difficulty right now in having this enormous inheritance of millions of years of sunlight, but releasing millions of years of carbon dioxide, but not being able to make decisions to be able to use it responsibly and to ensure that we don't destroy the only place in the entire universe that we know of where there's life, where there's energy that is available to life, and that conditions are such that we can maintain life. So I've talked about energy and why we have so many fossil fuels. And at this point, are there any questions? Does anybody want to get some more clarification about something I mentioned? Okay, well,
Is there other ways that energy can affect us, like other than carbon dioxide with fossil fuels? Is there any other way that it affects us badly?
yes. So as I mentioned, as an engineer, I've learned that energy, whenever you release it into its different forms, you're going to have side effects. You're going to have pollution. You're going to have things that you don't want to happen, but they still happen anyway. As a mechanical engineer, I understand this as work and heat. And the way that work and heat happens is that usually work is what you want to happen. An example would be like an internal combustion engine in a car. You want the car to just move. But most of the time when you're burning gasoline in your car, you end up with most of it turning into heat. And all it does is it makes your car warmer. It also turns into vibration, and you might feel this as shaking inside your car. So it's not all just motion, but it's also things that you don't want, like in a car, you don't want heat, you want motion, you want work. And you might get vibration, and vibration is also not good for you. It might make you dizzy. It might make you uncomfortable. And in addition to carbon dioxide and the reactions that come from burning fossil fuels, you get other pollution that can affect you, like nitrous oxides, carbon monoxide. Many of you know that it's very dangerous to have an internal combustion engine car running in the garage, because the carbon monoxide levels can get so high that you can go unconscious, and it can cause death. So every reaction that involves fossil fuels is going to have unwanted side effects. But even reactions of renewable energy, there are going to be things that we need to control and we need to responsibly clean up.
So you're basically saying for every reaction, there's an opposing reaction to it. Like for the car thing, that like you're gonna die if the carbon monoxide or whatever that thing is called. And why isn't there any trees on Earth left? Like, if all that carbon dioxide goes to trees, I mean, trees absorb it, but it's not enough. Like, people are cutting them down.
Right. The reason why is because they're clearing space. And the reason why they're clearing space is because they want to build buildings. They want to build cities. They want to build factories. They want to build places where people can build schools and build hospitals. They're clearing that land, but that land is taking away the trees. And for every tree that's cut down, that's like a carbon dioxide scrubber for our planet Earth, which is like our giant spaceship. And every tree can supply enough oxygen for 4 people. Every time we cut down a fully grown tree, that's 4 people that just lost their oxygen supply. But the problem is that with adults playing this game of the economy, unfortunately, adults feel compelled to, in order to have a job, in order to make money, in order to provide for their family, that they have to cut down these trees, and they have to clear the space, and they have to build all these buildings. But they don't think about and don't consider the alternatives, which is to leave the natural space alone and to come up with better ways to be able to provide for the needs of their family and for all of their country and human civilization without taking away the planet's life support system. I think this is something that adults have a problem with. They don't think of the Earth as a giant spaceship. They don't think of it as having precious capacity that we got to make sure the spaceship doesn't break down, because we don't have another planet to be able to go to. There is no planet B. We only have planet Earth. Any other questions?
Excuse me, sir.
Yes.
So I was saying, like as you said, the economic game the adults are playing, which we because of which we are following the rules of the economy and not of the universe. So I'm
Yes.
saying that the resources and the energy that we are exploiting for the sake of the game of the economy, if we don't follow it, I think in the long term, like ultimately it is going to destroy that economy itself. It's like the
Yeah.
very reason for which we started this game and exploiting it, it is going to just destroy that. So
Right.
yes, and like being a geography student, I would like to ask a question to you, because this has been in my mind for days. That like due to very they say that like mostly in lower standards we study that trees absorb all the oxygen and uh, like they absorb all the carbon dioxide and they give us oxygen. But
Yes.
I have also heard that phytoplanktons are those the creatures in the universe, like
Mm.
the creatures in the ocean, phytoplanktons. They can absorb. They absorb very much. Like they can absorb carbon dioxide, and through photosynthesis, when they you produce their food, they also give out oxygen.
Yes.
So I'm saying, if because of global warming, like we know that uh, the all the that solar radiation that Earth absorb, majority of that heat is like absorbed by oceans. So if the oceans absorb very much heat and like they get warmer, and then the
Right.
habitat of phytoplanktons, that habitat will also get starting warmer, and that marine biodiversity of the phytoplanktons, and then there are those like coral polyps that form like the coral barrier reef around Australia, all those
Yes.
type of things. So I'm saying, if this starts happen, and if we imagine a situation that these coral reefs which are around us, they
Mhm.
start to disappear, and if these phytoplankton creatures they also start to going extinct, then what type of consequences we will have to face?
Yes, that's a very good point. It's not only trees. Most of the Earth is actually ocean, and only about a third of, less than a third of the Earth is land. And the ocean has a tremendous part of taking out the carbon dioxide and releasing oxygen. And although we focus on land and we focus on the effects of land, there's a tremendous effect of carbon dioxide being absorbed by the oceans and making the water in the ocean more acidic, meaning that the ocean does not have the right chemistry anymore for the phytoplankton to be able to thrive. And as the phytoplankton die out, it's a similar situation to trees being cut down on land. You have less and less ability to be able to absorb the carbon dioxide. And a lot of the carbon dioxide being absorbed is by the water rather than by the plants. The plants can turn that carbon dioxide back into oxygen, but when it's absorbed by the water, it changes the chemistry of the water, making it more and more painful for the ocean life to be able to survive and to thrive. So we have less and less ability to be able to absorb the pollution because we're playing this game of the economy thoughtlessly. I mean, we as adults, and not really taking seriously the consequences for not only us but future generations, your generation. And your generation isn't at a point yet where you can make the decisions, you can play the game, you can make sure that the rules of the game are changed. But you are in a situation where you can wake adults up. So if there aren't any other questions, I'm going to move on to the next part of my talk. So we talked about energy. We talked about why we have so many fossil fuels. I think the major point that I want to make is that in studying energy, we have a very special situation here on Earth. We have a very special situation with life on Earth. And it's very, very unusual throughout the entire universe. I showed you that chessboard where we're a very, very tiny part of the entire universe. But the rules of the universe don't prefer this special situation we have on Earth. Rather, most of the universe is a mess. And we're turning our special, special place into a mess because we're not being careful about how we spend the inheritance that we got from all the trees and the plant life that died and collected the sunlight for our inheritance. We don't have renewable energy sources. That means that the fossil fuels are not renewable because it took millions of years for them to become the special things that we could burn and that we call fuels that we can use for powering our civilization right now. But when we burn them, it will take many, many millions of years, many, many human lifetimes to be able to get the same processes that made the fossil fuels in the first place. So they're not renewable because once they're burned, it will take way, way too long on the human timescale to get them back. So moving on from energy and fossil fuels, I'm going to talk about my journey as an energy pioneer and what I hope I can help you learn about your journeys as an energy pioneer and for you to be able to make a difference that I unfortunately was not able to over my energy journey. So when I started as an energy pioneer, I started as a mechanical engineering student at the University of Illinois. And I was thinking in terms of being a pioneer as a researcher. And that's a career path where you do research into new technologies and you help those new technologies become possible and become affordable to people. So I started a job at ExxonMobil, and that is one of the world's largest oil and gas companies. At the time when I started work at ExxonMobil, it was calling itself an energy company because it was telling recruits like me that ExxonMobil is not only oil and gas, that we will be able to transition to other forms of energy. So we're an energy company that will make that transition along with the rest of society responsibly. And being such a large company, my thought was that surely they have this responsibility to society. Surely they are compelled by their size and by their respect that is given to them to transition away from fossil fuels. And I, graduating from the University of Illinois back in 2003, I had the expectation that I would see the transition away from fossil fuels over my career. I had the expectation that climate change, which is already being seen as a major problem when I was back at the university, would be taken seriously and that I would be part of the solution, part of the effort to move away from fossil fuels for the sake of avoiding catastrophic climate change. But what I found over the course of my career was that even though I was working at the upstream research company of ExxonMobil, and we were supposed to be doing research, I was finding that the work that I was doing was not transitioning away from fossil fuels. Instead, it was being used to maintain more of the same and to play the game of the economy rather than the game of making sure that we use our inheritance responsibly and we guarantee good living conditions for future generations of not only humans, but all of life on Earth. So it's with some sadness that I show you this, that over the course of my career, what my career amounted to. So I'm going to show you the awards that I was given as a researcher at ExxonMobil. This award is for innovation, creativity, and recognition. And the reason why they put a giant iceberg on it was to give the idea that even though you only see a little bit of an iceberg on the top, there's a huge amount of the iceberg underneath the water. And that is really all the creativity and innovation that researchers do in order to create the technologies that people take for granted. And that was the purpose of this. But to me, when I received this award and when I saw this picture, what I thought of was the glaciers melting. What I thought of was the rapidly warming oceans because of the increased carbon dioxide. And what I thought of was that the award that I got this for, the award that was given to me was for technology that I developed that helped make fossil fuels cheaper so that more people can use more fossil fuels. It had nothing to do with transitioning away from fossil fuels. This other award I got just a couple years before I quit ExxonMobil was for a drilling technology. It got the Technical Achievement Award. It was called the Drilling Advisory System. And it's kind of like GPS for drilling, where you use GPS in a car to help you get to a location. You can use something like GPS in drilling to make it so that you can drill faster. And in this case, the technology I worked on helped make drilling 25% faster than it was before. I guess in my entire career, the award that made the most difference to me was not these awards that reminded me of how I wasn't helping the transition away from fossil fuels, but this award from my colleagues who appreciated how much I love basketball. Having grown up in the Chicago area, my favorite basketball player was Michael Jordan. And this was a personal award that my colleagues gave me to remind me that there was creativity, there was camaraderie, there was a lot of good feelings among my coworkers at the company. But for all of the creativity and all the innovation, all the friendship that we had, we weren't doing what we needed to do to help society transition away from fossil fuels. Instead, we're making people even more addicted to fossil fuels and encouraging people to buy even bigger cars, because all the technology that we did that made fossil fuels cheaper, that encouraged people, because of low gas prices, to buy even bigger cars and bigger homes, and to worry even less about the price that we're going to leave to future generations by burning fossil fuels without responsibility. So I felt disillusioned by this. I felt that I wasn't really being an energy pioneer. I wasn't really moving energy in a new direction and helping people transition away from fossil fuels. I couldn't do this at ExxonMobil. And I realized that what was under my control was my decision about my own personal life, my own day-to-day life. I couldn't do much as an employee at ExxonMobil, so I knew I was going to quit at some point. But I had to convince my wife and my daughter to go along with me, and that we had control to be energy pioneers, even if I didn't have a job as an energy pioneer. And that was to move to the Geos neighborhood that I'm standing in right here. The Geos neighborhood is a place of 28 homes. That's my neighbor on the south side. And that's my neighbor on my west side. And we have 28 homes that are built with solar panels on the roof. And you can see the solar panels there for my neighbor. And you can't see the solar panels on this side because I'm looking south in this case. And the solar panels are on the south side of our home. So that's why you can see the south side of that home. That's why I can see their solar panels. So as energy pioneers in this neighborhood, what does it mean to have solar panel, and what does it mean to have geothermal? Well, we have houses built here to be net zero and zero emission. And net zero, what that means is that our houses get as much energy from the sun as we use throughout the year. And what zero emission means is that we don't have any pipes sticking out of our houses that are spewing out pollution, particularly carbon dioxide. So net zero means that we have virtually zero electricity and gas bills. We definitely have zero gas bills because we don't have any gas. We don't have any what they call natural gas, which is actually mostly methane gas. And methane gas is poisonous. It's not something you want to have filling your home. It's also explosive. So some homes have exploded because of too much methane gas leaking into the home. And it's invisible. You can't smell it. So in the pipeline, what they do with methane gas is they add an odorant to make it smell really bad, smell like rotten eggs. So if your house were filling up with natural gas, you would be able to smell it. But otherwise, methane gas is like carbon dioxide in that is invisible. You can't smell it. And even worse, when it leaks into the atmosphere, it is more than 80 times more potent than carbon dioxide in trapping heat and warming the earth. So that's part of the reason why we don't want to have methane gas in our houses. But net zero means that we don't have gas, so we have no gas bills. So we have zero gas bills monthly. For electricity, we don't have quite zero because the electricity company here in Colorado, even if you generate more electricity than you use, they still charge you $6. So we can't avoid that $6 fee, but otherwise it is zero in the sense that we generate more electricity than we use. Now, this is throughout the year, though, because during the summer, we generate much more electricity than we use, while during the winter, there are many days where it's cloudy, where the sun is low in the sky, and we generate less electricity than we use. So what happens is our electricity company gives us credit for how much solar power we generated more than what we needed during the summer, and they give us credit for it. So during the winter, even if we're generating less than what we use, we get that credit from the summer back. Now, there is some things that still can be improved. We're pioneering neighborhood here in that our houses are net zero and zero emission, but there are still things that can be improved. One thing that can be improved is that the electricity that comes from the electric company, it's not all made by renewable energy. Some of it is made by coal. Some of it is made by natural gas. And so whenever we have to take electricity from the utility, we are still resulting in some carbon dioxide emissions, not directly at our house because our house is zero emission, but the fact that the electricity came from a fossil fuel source means there was carbon dioxide that went out into the air because of us. So what we try to do is we try to minimize the amount of electricity that we take from the grid. And that means doing things to help take advantage of natural sources of energy rather than having to use our electricity to be able to heat and keep our homes comfortable. So I think this is the end of my second topic, which is what does it mean to be an energy pioneer? And what does net zero and zero emission mean? So I think this would be a good time for any questions. Do you have any thoughts about what I just talked about?
Excuse me, sir.
Yes.
Just asking, as you mentioned about that in your neighborhood, all the houses have solar panels on their roofs.
Yes.
So is it like that for you that all the solar energy that you produce and all of it, if converted into electricity, so all the solar electricity that you get, so you can use it personally for yourself, or you are like bound to sell some part of it to the government?
Yeah. So like I mentioned before, whenever there's any sort of reaction in the real world, you don't get all of the energy into useful form. So we get sunlight on our solar panels, but only about 15 to 20% of it actually becomes electricity. And just like the example that I mentioned, where when you have a gasoline car, a lot of the energy just turns into heat and vibration and sound. It's funny that people love the sound and they don't like electric cars because they're quiet. But the reason why it's noisy on a gasoline car is because that's energy that's being wasted, that's not going to your wheels. The same thing with solar panels. When the sunlight falls on the solar panels, much of the sunlight ends up becoming heat. All it does is it warms up the solar panel. You get about 15 to 20% becoming electricity. And then when that electricity goes throughout your house, there's small percentages that are lost as it goes throughout your house. That electricity is available to the house to be used, but if we don't use all the electricity the solar panel generates, it actually goes back to the grid. It goes back to the transmission line so that our neighbors can use it. It goes back to people outside of our neighborhood so that they can use the electricity. So it's not that we're selling electricity back to the government. It's that every time we generate more electricity than we use, our electricity company is measuring it and they're giving us credit for it and saying, okay, you generated this much more electricity than you needed. In the winter, we'll give you that credit back so that you don't have to pay for the additional electricity you're taking from the grid during the winter because you gave more than you took during the summer. Does that answer your question?
Yes, so thank you.
Okay. Any other questions?
Yes. So, like when you're making energy with solar panels, from getting the heat and sunlight, and then producing it to electricity, like
Yes.
give it to the government, and then they give you credit in the winter.
Yeah, it's not the government; it's the utility, which is the electricity company. And the electricity company, it's kind of like if you had like a cell phone plan, and your cell phone gives you a certain number of minutes, and you don't use all those minutes in a month. Well, then your telephone company can say, okay, you didn't use like 100 minutes, but later on in another month, you used 100 minutes more than what you were allowed. So they give you the credit, and you get that credit back in a later month when you're using more electricity than you're generating from solar power.
Okay, thank you.
You're welcome. Okay.
I don't necessarily have a question, but I just wanted to say that I really appreciate like your analogies, like your comparison. Like I think it's like really cool and it helps a lot of the kids understand like what you're saying, like how you compared it to the Rubik's Cube and the Monopoly game and all that. And also just a really inspirational story so far. So yeah, I just want to thank you for that.
Thanks. I appreciate your kind words. So if there aren't any questions, I'll move on.
Let's go ahead, Darlan. We have a hard stop at 11. So
okay.
If the kids have any questions, maybe they can ask at the end.
Okay.
Yeah, thank you.
Okay, sounds good. Thanks for letting me know. So what I want to move on to next is the third topic, which is energy around the house. I've mentioned some of the energy around the house, but what I want to talk about is not the electricity. We've talked a lot about electricity, but about heat and about things that you can do around the house to be able to reduce the impact of carbon dioxide emissions within your house. So I didn't talk about heat and I didn't talk about geothermal. So I'm going to show you a snapshot of how geothermal works. So this is a figure showing the sun at the top, and at the surface of the sun, the temperature is 6,000 degrees centigrade. And from the Earth, it's 150 million kilometers. But if you go to the center of the Earth, the core of the Earth is at the same temperature. It is also at 6,000 degrees centigrade. And instead of going 150 million kilometers, you only have to go about 6,500 kilometers to the Earth's surface. This is how geothermal works. It's the fact that the Earth's core is very warm, and through magma and heat transfer, the warmth of the Earth's core gets to the surface. You only have to drill down about 6 or 7 feet into the ground, and you will reach a pretty constant temperature for the Earth. In the case of Colorado, it's about 55 degrees Fahrenheit. So this 55 degrees Fahrenheit, if you tap into it, you can use it to cool your home during the summer and warm your home during the winter. So geothermal is one way that you can avoid having to use gas. But without geothermal, there's still many things that you can do around the house to be able to reduce the amount of heating that you need to do. One thing is something I've already shown you, which is having your windows open. And particularly the south side windows, those are the windows where the sun is going to be shining into your house. And where you can, where you can open the shades and let the south side windows let sun in, that will help heat your home during the winter. So you don't have to use your furnace as much to heat the home. Conversely, during the summer, the sun is going to be higher up in the sky, but you can pull the shades down so that the sun doesn't heat up your home during the summer, and you can help keep your house cooler during the summer. The other thing that you can consider around your house is the insulation of your door. The door is one place where there's a tremendous amount of leakage. And one thing you can do is you can open your door and you can feel the two sides of the door. You can feel one side and feel the other side. Now, if you feel one side is very cold and the other side is warm, that means that your door has good insulation. It means that it keeps a big temperature difference between the outside and the inside so that you don't waste energy and leak it out to the outside. But if you find that you put your hand on the door and it's actually cold, it's almost as cold as it is outside, it means that your door is very leaky. It's allowing a lot of heat to escape from your home. So these are some things that you can do around the house to help reduce the amount of gas that needs to be burned in order to warm your house. The other thing that you can consider is that in your house, there's something called a heat pump, but you haven't heard it called a heat pump. It's your refrigerator. Your refrigerator is a heat pump. What it does is it makes the inside very, very cold by making the outside warmer. The reason why it's called a pump is it's because it's pumping heat that's inside your refrigerator out into your house. So you may not notice it, but your house is getting warmer as the inside of your refrigerator is getting colder. That can be done for your entire house. You might call it an air conditioner, but an air conditioner can only go one way. It can only cool your house. It also wastes a lot of electricity. It has to use a lot of electricity in order to keep your house cool. A heat pump is better than an air conditioner because for every kilowatt hour of electricity that you use for a heat pump, you can get 3 to 5 times the amount of energy transferred in and out of your house. So a heat pump can not only cool your house like a refrigerator, but can also warm your house. So it can replace your furnace and you don't need to use gas anymore in order to warm your house. And it can do this much more efficiently than a regular air conditioner. It can do this so that every kilowatt hour of electricity you use, you get 3 to 5 times the kilowatt hour of heat. So heat pumps is something that you could consider if ever your house has the air conditioner break down, the gas furnace is getting old. This is called a retrofit, where you can replace the things that are inefficient and that use gas with heat pumps. So the last thing that I will mention that you can consider around the house is your car. So I'm going to go down into the garage and show you the thing that could store the most energy for your house. And I talked about energy as being things that are happening and what could happen. Well, batteries are what could happen. So I'm going into the garage right now, and I'm showing you 2 electric vehicles. There's an electric vehicle over here on the right, an electric vehicle here on the left. And these electric vehicles, they are like the homes in that they're net zero. They take electricity from the sun, from the solar panels, and they're zero emission. They have no tailpipes. If you check in the back of the car, you won't be able to find any tailpipes. And without any tailpipes, that means that you're truly zero emission. Now, what makes these cars different from a gasoline car is you can pop open a port, and just like your tablet or your computer, there's a port where you can plug in electrical cable. And in the garage, this is a 220 volt port. This provides enough electricity to be able to charge up the car so that overnight you can get more than 200 miles of range. So just like a computer, just like a tablet, you can charge up an electric vehicle. And this giant battery is on wheels. So in the next generation, you can not only charge these giant batteries, these batteries can also power your home. So if there was ever a power outage, the electricity could be reversed so that your home runs on your electric vehicle. So this is another thing that you can consider when your parents are finding that the gas car is getting old and it needs to be replaced. Rather than replacing it with another gas car that's going to make you dependent on fossil fuels and results in greenhouse gas emissions, consider an electric vehicle. So that concludes the third part that I was going to talk about, which was what you can do around the home. Are there any questions? Okay, there's one thing that I didn't mention that I want to get in, which is your stove. Your stove uses something to heat it up. If you're using an electric stove, that's great. You're using electricity to be able to generate the heat to cook. But if you're using a gas stove, you have similar problems to what I mentioned about carbon dioxide in your house. Next time, if you have one of these sensors for carbon dioxide, when you turn the gas stove on, use this to measure how much the carbon dioxide level is going up. Studies have found that kids are 24% more likely to develop lifetime asthma around gas stoves than around electric stoves. And one thing that you could do is, even if you can't replace the gas stove right now, you can consider coming up with recipes that your parents could use that use portable electric stoves. These portable electric stoves aren't very expensive. You could use these to cook foods without generating the carbon dioxide and pollution that a gas stove would. And you can start to learn how to be able to transition away from gas stove cooking to electric cooking. So having said that, any other questions? Okay, I'm going to go to the final part. The final part is, what does it mean to be grown up? And how do we change things so that humans are more grown up about how we use energy? I mentioned before that instead of the chessboard of the universe that has the rules of the universe, we're instead playing a game called the economy. And the ones with the most money are the ones with the most power. They're the ones who are the winners of the game, the ones who get to decide what is going to be done, how many trees are going to be chopped down, how many things are going to be developed, whether we use electric appliances or whether we use gas appliances, how new houses are built, whether new houses are built like my neighborhood or whether they're built like traditional neighborhoods that use gas and create a lot of pollution. So unfortunately, the reason why you might see the entire world and adults not making grown-up decisions is because many of the people who are making the decisions are not thinking like grown-ups. And what does it mean to be grown up? The way I think of grown up is that people don't grow to be 100 feet tall. We grow to some height and then we become mature. We realize that there are limits and that we can't grow forever. And to be grown up is to realize that we can't grow forever. We have to understand that we live on a finite planet. we have to understand that we have to care about things more than just ourselves. We have to care about more than just whether we're winning the game of the economy, but about the bigger scheme of things, about whether we're leaving a good future for the future, for future generations. And being grown up is about being able to care more about just yourself, care more than just about your own family, care more than just about your own country, care for all of humanity and all of life on the planet. And we need your help. We adults need your help. We need kids to help wake adults up, especially the adults who have the power to make decisions. So we need your voice. We need you to help spread the word about how it's entirely possible right now for us to make grown-up decisions. And we need your help to encourage adults to make those grown-up decisions. So with that, have a few minutes left. Any final questions?
Can I say something?
Sure.
Well, when I was cooking pancakes on the stove, my head started getting really hot and I felt really tired. So I stepped away from the stove. And then once I came back, the pancakes were burnt. I don't think I have to say that. And then what happened is that, again, whenever I go near the stove, the heat and radiation made me like tired and drowsy. Like I didn't have the energy to eat anything.
Is this a gas stove or an electric stove?
It's gas.
What might be making you feel bad is not the heat and the radiation, but actually the carbon dioxide that you can't even smell, but that is going into your nose, and as well as the pollution from the burning of the natural gas. So you might want to consider learning how to use a portable electric stove to cook your pancakes. Another idea, if your family can replace the gas stove, is to put an induction stove. Induction stoves are even better than gas stoves for cooking, and they use only electricity.
Those are nice. And also, my friend has these electric stoves, and whenever I cook near them, like whenever I help the moms and whenever we have a gathering, nothing happens to me. Like even if I'm by the stove, I just feel nothing. I don't feel anything.
Yes, because the electric stoves are not creating carbon dioxide pollution.
Okay.
Yeah. So thank you so much, Darlon. I think in the interest of time, Jashu, just go ahead and we can probably say thank you.
You're very welcome. Please feel free to email me if you have further questions.
Definitely. Jashu, you're on mute.
Yeah, I just want to say,
Yeah.
like, again, just thank you so much for being here with us today. And it was really like a great experience with all the interactive, like how you showed us around your house and everything. So I guess all the kids were really interested, and it was great and very inspirational to hear from you today.
Thank you. It was my pleasure.
Thank you so much, Darlon. I'll be sharing you the link as well. Thank you once again. Thank you all.